Have you ever gazed up at the night sky and wondered what causes the beautiful dancing lights known as auroras? These celestial displays of green, purple, red, yellow, blue, and even pink lights, known as auroras or polar lights, are one of nature's most breathtaking sights. They're a cosmic ballet, a celestial symphony playing out on the grandest stage of all, our sky. These ethereal light shows are most commonly seen in the polar regions, near the North and South poles. For those lucky enough to witness them, they create a spectacle that leaves a lasting impression, a moment forever etched in memory. But these aren't just random lights flickering in the night. They're the result of a fascinating interplay between our planet and the sun, a dance of particles and magnetic fields. So, you might wonder, what exactly causes these captivating lights to appear in the sky? It's time to break that down. The story of auroras begins with the sun, our very own star. The sun, in all its blazing glory, continuously throws out a stream of charged particles known as the solar wind. This wind, invisible to the naked eye, streams out into space at astonishing speeds, carrying with it the sun's magnetic field. Now let's talk about these charged particles. They're essentially protons and electrons flung out from the sun's atmosphere. They are full of energy and are on a collision course with Earth. But don't fret, our planet's magnetic field acts like a shield, deflecting most of these particles. However, some particles manage to slip through this protective barrier, especially near the poles where the magnetic field is weaker. These particles are then drawn towards the Earth's magnetic poles, making the long journey from the sun, across space, to our planet. So these charged particles travel about 93 million miles before they reach our planet. But what happens when they get here? Welcome to Earth's magnetic field, the stage where the aurora lights perform their magical dance. Think of it as Earth's protective shield, an invisible force field that plays a crucial role in orchestrating the mesmerizing light show of the auroras. This magnetic field acts as a guide, directing the charged particles from the solar wind towards the poles. It's like a cosmic GPS, steering these particles on a path that leads them to the north and south poles. However, not all particles from the solar wind get to join the party. The magnetic field deflects most of them, sending them back into space. But a select few are allowed to sneak through, gaining entry into the Earth's upper atmosphere. These chosen particles, now in the Earth's atmosphere, are on a collision course with the gases present there. And it's at this point that the stage is set for the auroras. And when these particles meet the gases in our atmosphere, that's when the real magic happens. Now imagine the moment when the solar particles meet the gases in our atmosphere. The solar particles, charged with energy from their sun-swept journey, collide with the atmospheric gases. This interaction causes the gases to become excited, a scientific term indicating that they've absorbed the energy. But these gases can't hold on to this energy forever, and as they return to their normal state, they release the energy in the form of light. This light is what we see as the vibrant colors of an aurora. The color of the aurora is determined by the type of gas the solar particles interact with. Oxygen produces green or brownish-red hues, while nitrogen results in blue or purplish-red colors. Each collision, each release of light contributes to the grand tapestry of colors that ripple and dance across the night sky. And voila, you have the stunning light show we call an aurora. Now that you know the science behind auroras, wouldn't you want to witness this celestial ballet? Imagine standing beneath the starlit sky, watching the night come alive with a dance of colors. Where, you might ask? The Arctic and Antarctic regions are prime spots for such a spectacle. The long, dark winter months provide the perfect backdrop for the aurora's light show. Places like Fairbanks, Alaska, and Tromsø, Norway, are renowned for their frequent and vibrant aurora displays. Down south, the Antarctic's isolation and pristine environment make it an equally captivating, albeit less accessible viewing point for the aurora australis. If you're not a fan of the cold, worry not. You can also catch the aurora borealis from the northernmost parts of Scotland during peak winter months. The key is to choose a spot with minimal light pollution, clear skies, and ideally closer to the poles. So, pack your bags and get ready to witness one of nature's most beautiful phenomena, the aurora.